everybody. Welcome to a new hackathon session. And yeah, today we have Thomas Langer from the Helidon team at Oracle, and he's talking about Helidon DB Client. Hey, Thomas, welcome. Good to have you.
All right, so my name is Tomáš Langer. I'm from the Czech Republic. I work for Oracle. My official title is a bit complicated, but I'm acting as a Helidon architect. So when it comes to features of Helidon, the way it's designed, it's mostly going to me. So if you have any questions or suggestions, you can contact either me or contact our team through our GitHub issue tracker. We have safe harbor. Everything we say can be changed. So I want to give a very short introduction into Helidon for those who haven't heard about it before. Then a few words about DB Client, and then I will switch to code. And if time permits, we can have some Q&A. So Project Helidon, a very short description. It's a set of Java libraries for writing microservices. What we try to do is to give you quite a lot of modules that help you when creating a new microservice. It's very modular to allow you to really streamline your project to have as small footprint as possible, both on the disk and in memory. Helidon comes in what we call flavors. You can work with Helidon SE, which is our reactive approach to writing microservices. It's a very small, non-blocking micro framework that is code-centric. So basically, we try to make it in a way that if you want something to happen, you need to code it. You need to write a line of code for that. On the other side, we have Helidon MP, which stands for microprofile. And microprofile is a set of specifications that are styled similar to what Jakarta EE is doing. So it allows for declarative approach to writing microservices, where you annotate things, you inject stuff into your classes, and it works by magic. So I like to say that Helidon SE is the no magic framework, where Helidon MP is the one that allows for a certain amount of magic, that things happen outside of your code. Of course, there is a price for each. Reactive implementation is complicated. There is a lot of scaffolding that you need to do to be able to write good reactive applications. On the other hand, the declarative approach it has less scaffolding. You do everything synchronous, but the price you pay is usually in performance, parallelism, and so on. And of course, startup time. Helidon SE components, the blue ones are the ones that are considered production and stable. The green ones are now in experimental stage. DB Client that I will be talking about is one of the experimental features where by saying experimental, we are not saying we will remove it. What we are saying is that this feature may have backward incompatible changes even between non-major versions of Helidon. So if we find that there is an API that just doesn't work, or that could be way better, we don't deprecate and then remove, we just remove it and make sure we document it in our release notes. So people who try it can easily upgrade to the latest version. So I will now focus solely on DB Client. The rest, I think that there were already talks about that. So the DB Client is a reactive and non-blocking database client. It is not a driver. We are not building drivers for databases. We are just building the user API to query databases, to create inserts, updates, deletes, and so on. It supports existing blocking JDBC drivers because there's a huge support for basically any relational database in the JDBC world. We also support non-relational databases. Right now, we are using the connector to one other database, to Mongo, which already has a reactive driver. So that's like natively reactive. Of course, for JDBC, it cannot be natively reactive because JDBC drivers are blocking. So we are wrapping them in executor service. When we design a new feature for Helidon, we always think about three things that need to be available for when you create a microservice, and it's metrics, so you can know what's happening, how many times your services are called. It's tracing, so you can see in your trace, for example, in Zipkin or Jaeger tracer, what happened to your call, which goes across multiple microservices. And when you use Helidon DB Client, you can also trace to the level of an actual statement. You would see the statement that's being invoked in your trace, of course, without parameters. And health checks enable you to use, for example, Kubernetes probes. So you can add a health check for a database that will say that the database is up and running. One of the major design things that we decided when we were doing DB Client was to put the statements, externalize the statements from the code to configuration. And the reason for that is that we think that you should be in full control over the SQL statement that you are going to execute against your database, or in case of Mongo, the actual query that you will be creating. And this allows for a very nice thing that you can do with Helidon DB Client, and that's switch databases between environments without any changes in the jar file. So if you have a local environment which is using H2 in-memory database, you can just use H2 in-memory database. And if you need to change, a statement here or there because of data types, you will just have that development configuration have those correct statements. And then if you use Oracle database in production, you just switch using configuration. You don't need to go into your code and do any changes there. Extensibility that comes from the possibility to create your own implementations. You can also create services that allow some modification of the statements or of the queries, and you can also do things like mapping of database objects to objects. So one of the things Helidon DB Client is not, it is not an ORM tool. It does not have a layer of object to relationship mapping. It's really it executes statements, it gives you back either results in the form of how many records were updated or rows from the database. It will not give you an object of a specific type unless you build a mapper for it yourself. One of the things that Helidon Reactive is, what's very important there is you cannot block the thread you are running in. So if you use Helidon Web Server and you create an endpoint, you cannot block the thread. So if you use JDBC, obviously you would be in trouble because you would need to block the thread or create your own executor service, execute the whole JDBC in a different thread, and then return the response back. Helidon uses Flow API. So what we did with DB Client, we built a reactive layer on top of the blocking API of JDBC using executor services. The good thing for Helidon SE is that this layer actually provides a publisher of records. For example, if you do a query, that can then be processed by the web server. I will show all of that in the code. So as I said, it's a very short introduction, and it's time now to actually have a look how that works in Helidon. So I will be using the Helidon command line interface. You can find it on our documentation pages. You can download, it's a native executable currently available for Mac and for Linux. I think we may have already the Windows version. I didn't check. That's actually using Graal VM native image. We use it ourselves to build this executable. So I will be using Helidon SE. And from the archetypes, I want to use the database because that will have all the necessary stuff in the POM file, and I can demonstrate how it works on top of that. I will just change the name, so I will call it Helidon DB Client. I don't really care that much about that. Okay, I don't want to start development loop. I want to show everything by hand. So I will just do one small thing. I will move it to a different name because of my IDE that sometimes caches too much. So let's switch into it and let's have a look what we created. So there is a README you can go through if you are interested in finding out everything yourself. I will now guide you through the project. So the first thing that we want to have a look at is our POM file. Our main build tool is Maven. We also have support, limited support for Gradle. I will be showing everything in Maven because I know this. I don't know Gradle that much. So this is a standard Helidon SE application. You can see there is a parent application that defines all the dependency management. You could also have a standalone application with your own parents. It requires just a different configuration that we also support. So let's have a look at what we do with DB Client. There is a few dependencies. As I said before, Helidon is very modular. So each component, if you want to add metrics, there is a module for metrics. We don't want to have metrics on class path unless you actually want to use it. So there is a bunch of modules that you want to add. If you want to use JDBC, you can see there is also MongoDB, which we actually don't use in the example I will be showing, but that was because you could switch, I think, in the example between the two databases. So I will just keep it as it is. So what modules we have? We have the JDBC DB client, which we will be using. We have tracing support to be able to connect the database client into tracing, such as I said before, Jaeger or Zipkin, or other open tracing implementations. We have support for metrics, so you can add metrics from Helidon DB client into the metrics support in Helidon itself. There are specific metrics for the JDBC connection pool. There is health check support for DB client, and then we have JSON-P support. This is actually automated mapping from a row in the database into a JSON-P JSON object. So that's the maximum of our ORM. You can actually get a JSON object from the database. Hickory connection pool is used automatically by our JDBC client, so that's not really required here. And then we have the web server stuff related to the normal use of Helidon. The driver I will be using is the H2 driver. I will just switch to the repackaged one from Helidon. And the reason is that the repackaged driver supports native image generation, which I will also show as part of this. And then we have some testing dependencies, which we don't care about right now. Okay, so that was the POM file. As you can see, there is quite a lot of dependencies. As I said before, Helidon is very modular, and each dependency is one feature that you can add to your project. So the next will be our configuration. So application YAML, that's the default configuration used by Helidon. It will be picked up automatically. What I will change here, by default, this example that you get is running in memory, but because I want to run native image, it cannot be using an in-memory database. We need to connect through TCP. So I will switch to a remote database. I will just have a port 9092 because I have a Docker image on my machine that's running on this port. Then there is a lot of configuration. Basically, all of this can be removed. That's really not needed unless you want to add metrics for the pool. You really need just the URL, username, and password. So all of this is optional. Services are used to define things like metric support and tracing support. So for each service that you want to add, there is a documentation for it where you see how to add that service to DB client. Right now, you can see that we are adding an overall metric of type meter that will be added for each statement executed. And then the important part, the statements that we use. So here are all the statements. Maybe a short, what I wanted to show here is you use the database language of the database that you use. So right now, this is very specific for H2. As I said, if you run in production on Oracle, you would probably modify these statements to match your Oracle database. to use whatever specific things you need to tune your performance, we leave that in the hands of the developer. One thing, you can use two styles of parameters. So you can see that the second one is the standard JDBC approach. You have a question mark, which stands in for a parameter, which is indexed. So you basically have to provide the parameters in the correct order, and they will be added to your statement. The second approach is providing a named parameter. So if you do colon and a name, you can provide, for example, a hash map that contains your parameter to value mapping, or you can just set one parameter after another using the API. So this is the configuration. I have switched to remote, so that should be it. Logging.properties, we are using Java util logging, so this is just configuration of the logging output. There is also an interesting directory here that it's called native image, and this is configuration for the GraalVM native image that we use. So you can see that there is one argument added, and then we are adding our JSON binding classes for reflection. If you don't do this, then in native image, you would not be able to create an instance or set anything using reflection, because native image removes all reflection access from all classes unless you explicitly declare them. So that's the part that we do here. Okay, so let's have a look on the source code now. We try to call the main class of the application main, so it's easy to locate where everything starts. In the main class, there are two really important methods. So there is the method that actually sets up the web server. So we have an endpoint you can call to invoke the application. The web server reads configuration. You can see that we have here we are reading the configuration of the node server. So let me quickly switch to the configuration just to show what's there. We can see that there is server, which is a port of 8080, and the host is any address. The web server is configured, which endpoints will be available is configured using our routing. So you can see that we are providing here the routing to the web server, and that's the second important method of the main class where we set up the routing. So first, we get our configuration for the DB client. If I switch here, you can see that it's the DB node that contains all the information. Then we build the DB client instance from this configuration. And you can see here we are setting up our health checks. As I said, one line for everything you need to do. So in this case, we want to add a health check. There is a line for it, adding a health check. If this was Helidon microprofile, you would find out that there is no such thing. There would be just an annotation on the health check itself. So in SE, we code. This class is just used to initialize our database to create the schema and insert some initial data. Of course, this is mostly for the example. In real world, you would use some tool to set up your database. And then we register all the services. So we have the health check support, we have metrics support registered, and then we have our actual business service. So in this case, it's called Pokemon service because most of our team in Helidon plays Pokemon Go. So our examples are kind of Pokemon centric. So here I will now switch into the Pokemon service to show a bit how this works. So a web server service has one method that is doing all the configuration. And here we set up the routes that will be available on the endpoint. You can see that there is a few endpoints that just list stuff. So there is the Pokemon types, there is the list of Pokemons, and then we have two get methods for Pokemon, which is by name and by ID. We have a post method that allows you to create a new Pokemon in the database. And then we have a delete method that will delete a Pokemon by ID. These are the HTTP verbs. So this is the get method of HTTP, listening on this address and invoking this endpoint. So the endpoint is our reactive router. And I think that it's quite a good thing now. I can show that we have a small problem in our template, and I can explain on it why it matters that your code is reactive. So what you can see here is that, unfortunately, somebody who created this example called a get on a completion stage. Calling a get on a completion stage is a blocking operation. So what would happen here is that the DB client would execute, then it would map each row into the Pokemon type, and then it would collect the list and to wait until all the records were loaded from the database. So the thread that we have here would be blocked for the duration of the whole select, which is obviously not allowed because we would block native threads and that would break our server. To fix that, it's actually very simple. We just change it into a reactive code. So we want to send the response. And here, what you will see is that the map actually returns a multi, which is extending a flow.publisher. And luckily for us, our web server has a method that accepts a publisher of types. And the only thing we need to do here, we need to tell it what is the type of the publisher. So we say it's Pokemon type. And because we have JSON binding registered on the web server, it will automatically use JSON binding to serialize the Pokemon type into an actual JSON that will go across the stream. So by this simple change, I have made this fully reactive instead of blocking as we had it before. I will just quickly do the same thing for our second method. We just remove all this and say Pokemon class. There we go. And not only is our method much simpler, it's also correctly reactive. Now let's have a look on the DB client itself. So here you can see that there is an executor that you get from the DB client, and on that you can call various methods. The ones that we kind of hint at that you should be using are the ones starting with named. So there is named query, named get, and so on. These will look into the configuration for the statement name and execute that statement against the database. There are also methods that are like get or query, which actually allow you to provide a statement in runtime. And obviously, this will use prepared statement in the background, but you would need to create a statement that's valid for the database you are using right now. So as soon as you start using this method, you block yourself from being able to migrate to another database unless you use, like always JDBC and pure SQL, or you are absolutely certain that you will not need to switch between databases. The second approach that you can use is the verb create. So here in this example, this is an example that actually gets a single record. So we parse the parameter ID, and then we say create name get, and then we add a parameter. So this named query, you can see that the parameters are part of the signature. Here, when you do the create, you will get a statement, and on that you can do stuff like adding a parameter. So here we are adding a named parameter called ID and giving the Pokemon ID. The second example that we have is using sequential parameters, not named. So here we just send the parameter as part of the method call. Okay, so another thing that I wanted to show here is I talked about this one, that we are using JSON binding. And I also said we don't have an ORM mapping. And obviously here we get the result. So the result is the DB row from the database. And we map it into Pokemon. And this would not work unless you actually provide a mapper. So there is a mapper as part of this application. So if you create the application using Helidon init, you will get the same mapper. And you can see that we don't care about named and index parameters. We only have implemented the read method for Pokemon type in this case. And it obtains the parameters from the row and creates an instance of the correct type. So this is basically the implementation of the ORM that you would get with tools like JPA, which use reflection to do all this. We don't want to use reflection in SE because it's not very nice and it doesn't play nice with native image itself. All right, so we have the Pokemon service using JSON-B, and then we also have the part using JSON-P, and that we have, for example, here when we do get by name, we have a method called sendRow, and this uses the JSON object, and we just say, give me the row as JSON object. And luckily, we created this library for you, so this is available for anybody if you add the JSON-P, JSON processing library on your class path. Okay, so I think that it's now time to show how that compiles and works. So I will just clean package, but I need to skip test because I have something already in the database. And let's start with Java. So I will just start it with java -jar. And of course, it's called database se.jar. Okay. So our server is started. Now we can have a few curl commands to see what's happening. You can see that there are a few warnings. These are caused by our initializer because that tries to create the database tables and tries to insert the initial data, and it gets an exception because both the table was created before and the initial data are inside. So we don't, that just fails and warns you that it happened. Another warning that you will get is that you are using experimental features. We always do that when you use DB Client or other experimental features, so you understand that there is a certain risk that our APIs may change. So now I will call the okay, I managed to add something I didn't want there. So you can see that there is a set of Pokemon in my database. Maybe I can just show it as a JSON. These data that we see are coming from the JSON binding. So these are the fields in our Pokemon object that we have. Now I know which Pokemon are in, so I can get a single one by name, for example. So I will say name and then give it PG if I type it correctly. And we can say that we can see that we got the response. And you see that there is a capital ID and ID type. And this is caused by the difference that here we use JSON binding. So the fields were the fields of the object of our Pojo. Here we are using JSON processing. So the names of the fields are as the database provides them. Obviously, if you create an application, it's quite good to decide which one you want to use, because otherwise you would get inconsistent naming of your objects. I could also try to find something that's not there, which I get a 404 as expected. So this is all implemented in the example. So the next part that I want to talk about is how does this look in our health checks and metrics? So let's have a look. I will query our metrics. What I'm doing here, I'm creating a request which explicitly asks for application JSON, because by default, you get a text representation which is compatible with Prometheus. I want to have JSON because it's easier to read. So I call the endpoint for metrics, and I just say I want to parse it using JSON PP. So there are a few things that you see. There is the vendor metrics. That's what we decided in Helidon to add in. We have the base metrics, which follow the microprofile metrics specification of what needs to be in the output. And then we have application metrics, which are specific to our application. And here you can see that we have all the meters for all the queries and updates and whatever we did that we have called. So you can see that create types was called once. That's our initializer. But select Pokemon by name was called twice because I invoked it twice from the command line. So for each type, you would see a nice output here. So you could analyze the usage of your application. The next endpoint that's available here, because we configured it, is the health check endpoint. And again, we can see that there is the overall outcome, which says up, and there is a single check that we have added, which is coming from the database. The name is based on, this is a JDBC DB client, and we are using the H2 database driver. So this will be available. If you used Oracle, it would be JDBC Oracle. So the health check is up, application is up and running. You don't need to restart it. So going back, I want to show now once more how this works. So we have the health support that we create, adding the DB client health check. We have the metrics support. We just use the default, which will create a metrics registry, and the DB client then registers the metrics into that. And we register it with a web server, and default endpoints are /health and /metrics. So those are the two endpoints I have called. The Pokemon service is listening on the root, and we have /Pokemon. I didn't show /type, so that will list types. Let me just quickly switch to that. So instead of health, I will say Pokemon /type, not Pokemon, but type, sorry. And again, we get all the types that we have right now in the database. I think that we should have all of them. I have shown the get for getting all Pokemon, for getting one by name and by ID. I didn't show the post, so I have a quick curl command here. I will just need to change the ID because I already have this one in. So there will be a very specific Pokemon today coming into the world. So we can see that we got inserted one values back. If I want to show what's happening, what is the response code? Let me just change the ID and the name, because we are expecting the name to be unique as well. So we can see that we got an OK response and inserted one values. And this is coming from our insert Pokemon. You can see that we are using the a helper tool from web server to create a handler. So we don't need to handle this reactively from the web server request. So the insert Pokemon method will be called with the request response and the class loaded from the request using JSON binding. And we just do response.send, and that's the reason why we get a 200 response. What we could also do is we could actually set a custom response. So we could say status. So for example, you could have a 204 saying that there is no content, which would be probably wrong in this case because we are sending string. But if you just send no content, it would be valid for a post request as well. Okay, so I have now done everything I wanted to show in the code. So let's have a look on the native image. I think that there were also presentations about it. So let me just build Maven. I will do package skip test and give it the profile native image. This should create a native image from our application using the Graal VM ahead of time compilation tool called native image. And again, you can see that when you build an application from Helidon using native image, it will complain or inform you that there may be some problems. So in this case, JDBC is tested only with Oracle, all the drivers and H2 drivers, and you need to have our explicit repackaged driver, which fixes stuff for native image so it works. Luckily for us, this application is following these rules, so we should get a native image built from this. It takes around 1.5 minutes, I think, on my machine, unless Zoom is eating too many resources. And the result is an executable file. So I will give it a few more seconds to finish. So it's done. And now if I okay, this is what I wanted. So I want /target/ and here we have the database SE. It's 42 megabytes. So that's the full executable of our native image. And if I run it, we can see that it works the same as if I run it on in here. I can list the types and do whatever I wanted. It's running against my local database. The advantage is that this is including your whole Java world, so you can just install this executable. If you wanted to use Java, the real stuff that I wanted to show is that the target libs directory is 11 megabytes. So those are all the dependencies of Helidon SE, including the database client and the driver for the database and all the other tools that we use. And the application itself, the jar file, you can see it's 21 or 22 kilobytes because we use the approach of called hollow jar. So it only contains your application and all the dependencies are in the libs directory. We can also have a look of on how many libraries that is. I managed to close my command line. That was very nice. So let's go back there. I want to do this, and I want to just show that we have 66 libraries right now as the full library list. And one of the reasons why we have so many is because, as I said several times, Helidon is very modular, so you can really just pick and choose the features that you want. So this is covering all I wanted to show about the DB client. Sorry about that. There's one more thing I wanted to show, and I wanted to show how it looks from Mongo. So this is an example configuration of MongoDB. So you can see that just by switching the configuration, we could actually do the same stuff with Mongo. You can see here that there is a select statement, which is just defining the collection and the query. If you have an ID, you actually query by ID. And again, you can use question mark. Here, if you have a named parameter, well, you need to use dollars instead of colon, because if you use colon, it would break the JSON string that's used inside of these statements. So this is a very similar example using MongoDB to do simple CRUD operations. So for non-relational databases, the DB client supports basically selects, updates, deletes, and inserts. Well, maybe one thing I can say about the DB client, we are right now working quite heavily on a full set of integration tests, adding new databases to make sure that it works with native image. We are also adding some new features. I'm currently working on the possibility to return generated IDs from inserts, which we don't have in the current version. And we are looking at several performance improvements. So obviously the development goes forward. And we are definitely looking for any feedback, even if the feedback would be that this doesn't make sense. It's also a good feedback. We are, we just want to know how that can be used and how we can improve our work. So for those who will be watching this from playback, as I said at the beginning, you can go to our GitHub pages. There is an issue tracker that is used by our team. We actually plan our work from this tracker, so whatever you see there is actually used by us to improve Helidon. So that's another way how you can follow up on this talk.
Thank you, everybody, for joining. See you tomorrow. Bye-bye. Thank you.
Thank you. Bye-bye.